Today we are doing lesson 5.2 extension, graphing proportional relationships. Our I can statements for today: I can use graphs to determine if two ratios form a proportion, and I can interpret graphs of proportional relationships. All right, so proportional relationships. There are several different ways we're going to be looking at proportional relationships today and in this chapter as well. So these are the kind of how proportional relationships look on both a table and on a graph. So if a relationship is proportional, that means both variables change at a constant rate. There's some sort of multiplication pattern that's occurring in a proportional relationship. So for example, a movie ticket costs $10 each. So here's the table of some points. If I bought 0 movie tickets, it costs $0. If I buy 1 movie ticket, it costs $10. 2 tickets is $20. 3 tickets is $30. Our multiplication pattern there is to take the number of movie tickets and then multiply times 10. So 0 times 10 equals 0. 1 times 10 equals 10. 2 times 10 equals 20. 3 times 10 equals 30. So when we have that multiplication or division relationship between our two different parts of our table, then that's going to be proportional. When we look at how a proportional relationship looks on a graph, here's what it looks like for that one that we just found. We had the point 0, 0. We had 110. We have 220. We have 330. And together, these for a straight line, it's got a constant slope here, and it starts at the point 0, 0. And that's going to be true for any proportional relationship. The graph of a proportional relationship must be a straight line that passes through the point 0, 0. So those are the two things we're looking for today when we're looking for proportional relationships. Straight line through the point 0, 0. All right, so here, which graphs show a proportional relationship? Go ahead and pause the video and write down what you think. All right, let's check our answer. So looking at A, it is a straight line, but it does not go through 0, 0. So no, that's not proportional. For B, it does go through 0, 0. It's right here, the origin, and it is a straight line. It's going down. It has a negative slope, and we'll talk about slope later in the chapter. But it is proportional. It's a straight line. It goes through 0, 0. All right, C is not proportional. It's straight line, but it does not go through 0, 0. D, yes, is proportional. It goes through the origin, 0, 0. And is a straight line. E is not proportional. It is not a straight line, and it does not go through 0, 0. And then F is not proportional. It is a straight line, but it does not go through 0, 0. So B and D are the proportional graphs on this slide. All right, so let's look at some problems here. First one says, use a graph to tell whether X and Y are in a proportional relationship. So we have tables here that we can use to help us with a proportional relationship, but they're asking us to use a graph, which means they want us to actually graph and see, is it a straight line through 0, 0. All right, so I'm going to go ahead and start by just drawing in an X and a Y axis. Okay. So my X's are going by 2's. So I'll do that as well. And I'm going to go 3 lines and then putting my number. When you are making your X-axis, you need to make sure that your spaces and your numbers are equal. So I did 3 spaces and a number and 3 spaces and a number. My numbers went up by 2's. You have to have consistent spaces and consistent numbers. All right, here I have 6, 8, 10. I can't just start at 6. I need to start at 0 and then use equal spaces until I get to the numbers that I want. So over here, I think I'm going to go up by 2s. Every 2 lines, I'm going to write a number and I'm going to go up by 2. So 2, 4, 6, 8, 10. All right, now that my graph is set up, I'm going to go ahead and plot my points. So I have 2, 6 over 2, up 6s right here. And then I have 4, 8. So over 4, up to 8. And then I have 6, 10. Okay, now that I have my points plotted, I'm going to draw a nice straight line. And I'm going to extend it through the entire graph space. So in both directions, I'm going to put the arrow on the ends. That shows the line goes on forever in both directions. Okay, so I made my graph, I've looked at my table, and now I need a yes or a no. So is this a proportional relationship? No, it's a straight line, but it does not go through 0, 0. So for A, we're going to write no. All right, now we're going to do the same thing for B. Okay. I need consistent spaces and consistent numbers. Again, I think I'm going to skip 3 lines in between and then go up by 1s on the bottom. And I'll do 3s over here too. 3 lines and then going up by 2s on the side. What you're going up by on the bottom does not have to be the same as what you go up by on the side. But in each side, you need to have consistent spacing and consistent numbers. All right, so first point, 1, 2, over 1, up 2. The bottom part, I should have marked it on my last one, and I'll go back and add it. It's where the x's go, the horizontal axis here. That's x. And this is y. Over, up. Okay, 2, 4. So over 2, up 4, over 3, up 6. All right, and then I'm going to connect my points into a line, and I'm going to extend it through my entire graph space. All right, so when I look at this graph, yeah, it's going to go through 0, 0. It is a straight line. So yes. If I wanted to check it with a multiplication pattern, remember we can use that to find proportional relationships. On this one, it would be times 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. It's called a constant of proportionality, what we're multiplying our x by to get to y. All right, go ahead and pause the video and try these two on your own. All right, let's check our answers. So we need to start by setting up a graph. And because these are all positive numbers, I'm just doing a 2-quadrant graph. Sorry, a one quadrant graph. Okay, let's see. I've got 2 to 5. 1, 2, 3, 4, 5. You have to be very careful with your spacing. So 1, 2, and a number, 1, 2, and a number, and so on. Okay. I can't just go up by 5, start at 5, and go up 7, 8, 9. Can't even start at 1 and go up by odd numbers because that's not going to give me consistent spaces between my numbers because 0 to 1 is 1 unit. So I need to go up by a consistent amount. I'm going to go up by 2s, and I'm just going to skip every other line. All right, now I'm ready to plot my points. X is 2, Y is 5, that would be there. 3 and 7. 4 and 9. And 5 and 11. All right, then I extend my line through my graph space. And I look to see, is it proportional? And for this one, it's a no. All right, let's take a look at this one. Remember, this is my x-axis. This is my y-axis. You don't have to label those on your own graphs. I'm just doing that to help you figure out how you're plotting your points. All right, this time I think I'm going to skip 3 lines because I don't have to go up quite as high. On here, I'm still going to go by 2s and skip every other line. All right, I'm ready to plot my points. So 1, 3 would be right here. 2, 6, 3, 9, and 4, 12. Did I do that right? Okay. And then I extend my line through my graph space. This one is a straight line and it goes through 0, 0. Yes. My constant of proportionality on this one would be a times 3. 1 times 3 is 3, 2 times 3 is 6. That's how I know it's proportional. All right, for our next one, the graph of a proportional relationship passes through the given points. Find y. Now, on this one, they didn't specifically say you had to use a graph. I do have a graph here to help you with this problem. So I'm going to show you a couple ways to do it. And we'll start with the graph. All right, so this is our y-axis, this is our x-axis, and for an ordered pair, like the ones listed, they're always xy. The x number comes first, and then the y number. Okay, so I'm going to go ahead and put some numbers here. Pay attention to how many spaces you're going in between each thing. Make sure it's the same. 2, 4, 6, 8. Okay, so I'm going to start by plotting the point that I do know, 4, 8. So over 4 up 8 would be right here. I do know, because it says it's proportional relationship, that it's also going to go through 0, 0, because any proportional relationship goes through 0, 0. So now I'm going to draw a line as straight as I can to connect my 2 points, and I'm going to extend it. Okay, so for 4, it's going to equal 8, and then 1, I want to know what y is. So I can look at 1, and I can follow that up to where it hits the line, and then I can go over to see what number it matches up with. So on this one, when x is 1, my y is going to be 2. Okay, so that's how I can get that answer from a graph. I could also set up a proportion to figure it out. And I could think about this like equivalent fractions. 4 over 8, and then 1 over y. And I could think about, okay, well, to get from 4, if I was like simplifying my fraction, to get to 4 to 1, I would divide by 4. So I could do 8 divided by 4 to get my y of 2. Or a third way would be to look at that constant of proportionality, that multiplication pattern. Because I know it's proportional, I know there's a multiplication pattern between my x and y values. 4 times 4 equals 8. So 1 times 4 equals y. All right, go ahead and try these next two. You do not have to use a graph, but you certainly can. All right, so let's go ahead and check 3 and 4. So for number 3, I'm just going to use that multiplication pattern here. I know 3 times 7 equals 21. So now I'm going to do 1 times 7, and that's going to equal y. So y equals 7. I chose not to graph that one because 21 is kind of a big number. It would take me a little while to get up there. So I certainly could, but I'm not going to. All right, let's take a look at this next one. 1.5 to 9 and 1 and y. This one's a little trickier because I've got that 1.5 here that I have to deal with. All right, so this time I'm going to set up a proportion. 1.5 to 9 and then 1 over y. To get from 1.5 to 1, I'm going to divide by 1.5. Anything divided by itself equals 1. So now that means I need to do 9 divided by 1.5. All right, so I'm going to move down and do my work below here. 9 divided by 1.5. I need to move a decimal, placeholder 0. So now I have 90 divided by 15. All right, and you might have to do a little guess and check to figure that out. But we are going to, believe it's going to be 6. Let's double check, just make sure that's right. 5 times 6 is 30. 6 times 1 is 6, plus 3 is 90. Okay, great. So my answer here for y equals 6. Let's go ahead and take a look at our next one. The graph shows the distance traveled by the Mars rover Curiosity is proportional to the time traveled. Interpret each plotted point in the graph. So when a problem asks you to interpret, that means explain. So for each point here, we need to explain what that means. So we'll start with 0, 0. In our explanation, we need to look at the information from the graph and use the labels that they give us. So in our explanation, we need to use something about inches and seconds. Needs to be part of our explanation. Okay, Curiosity rover at top speed. So I'm going to write in 0 seconds. The rover moved 0 inches. My next point here is 1, 1.5. Remember that first number is our x. So for my first number means the time. So in 1 second, the rover moved 1.5 inches. And then for 3, 4.5 in 3 seconds. The rover moved 4.5 inches. All right, go ahead and pause the video and try these two problems. All right, let's check our answers. So for our car, we've got 3 different things. Our labels, miles, hour. We need to include that information. So my first point is 0, 0. And 0 hours. the car, because we need to include something about our title, went 0 miles. 160 in 1 hour. My car went 60 miles. And then in 120, in 2 hours, the car went 120 miles. All right, over here, shrimp, dollars, pounds, shrimp. So that's what we've got to write about. 0, 0. All right. It cost $0 for 0 pounds of shrimp. $4.40. It costs $40 for 4 pounds of shrimp. Notice how the 4 came first here and I wrote it second here. It doesn't really matter what order you write it, just as long as whatever the first number is goes with the pounds and the second number goes with the dollars. Last one here, $7.70. It costs $70 for 7 pounds of shrimp. All right, and the last one. Is it possible to have a constant rate of change and not have a proportional relationship? Explain. When they say constant rate of change, that means a straight line. If you graph it, it's a straight line. Go ahead and pause the video and write down what you think. Okay, let's check our answers. So, is it possible to have a straight line or constant rate of change and not have a proportional relationship? Yes. It has to be a straight line and go through 0, 0. To have a proportional relationship. So you can have a graph of the straight line, but if the straight line is not through 0, 0, then it is not proportional.